Welcome to Metamins Academy. We have already discussed the concept of consistency and we solved some problems based on consistency and inconsistency in the previous lecture number 8. Right. In this class, in this lecture, we are going to learn some more problems based on consistency and inconsistency. So here these type of problems are somewhat different. Here you have a system of equations in which you are given lambda as a coefficient of z and mu as a constant on right hand side in the third equation, right? So you are asked to investigate the values of lambda and mu so that these equations have no solution, unique solution and infinite solutions. For what values of lambda and mu these three cases will arise. So that is what we have to investigate. Let us start writing the system of equations in matrix form. So if you write the given system in the matrix form, as we discussed in the previous lecture, we get 1, 1, 1. Here the coefficients are 1, 2, 3. In the third equation, the coefficients are 1, 2, lambda multiplied by x, y, z equal to the column matrix on the right hand side 6, 10, mu. Right. So this is Ax equal to B. So what is the augmented matrix? The augmented matrix, as we discussed in the previous lecture, is denoted by K and written as the matrices A and B side by side. So if you write, what you will get? You will get 1, 1, 1. Matrix B is 6. Here matrix A is 1, 2, 3, 1, 2, lambda. Here we need to write matrix B 10 and mu. What we have to do is you reduce this to echelon form, right? So first of all you have to make these two entries 0. For that we write R2 implies R2 minus R1, so that you will get 0 here. So how K will transform? There is no change in the first row, right? We will make changes to R2 and R3 only. So this is 0, this minus this 1, 3 minus 1, 2, 10 minus 6, 4. And R3 is R3 minus R1. It is 0 again, 2 minus 1, 1, lambda minus 1, mu minus 6. Now the next step is we have to get a 0 here in order to get the echelon form. So how to get a 0 here? You just subtract R2 from R3, R3 minus R2. So you take, we are going to modify R3 minus R2. So K is transformed into 1, 1, 1, 6, 0. There is no change in the second row. Third row is R3 minus R2, 0, lambda minus 1, minus 2, lambda minus 3, mu minus 6, minus 4 is mu minus 10. Now this is in the echelon form. Now we have to investigate for what values of lambda and mu, how the rank of A and rank of K is influenced. Case 1. Let us take case 1. If you take lambda is equal to 3 and mu not equal to 10, because you are asked to find no solution case, right? So I take lambda equal to 3 and mu not equal. That means I take some value for mu other than 10. Then what happens? Mu minus 10 is non-zero. Lambda minus 3 becomes 0 because lambda equal to 3. In that case, if lambda minus 3 is 0, what happens? This row becomes 0. In the matrix A, you have only 2 non-zero rows. This implies R equal to rank of A becomes 2, as 2 non-zero rows, right? Because lambda equal to 3, this becomes 0 and mu not equal to 10, this is non-zero. So if you consider the entire matrix K, in that you have all 3 non-zero rows. So we denote it by R dash, rank of K, it is 3. Here R is not equal to R dash. That means the rank of A is not equal to rank of K. This implies the system has, in this case, the system has no solution. System has no solution. When R is not equal to R dash, no solution. Next, case 2. When it comes to case 2, if it's a unique solution means what? R equal to R dash equal to N. R equal to R dash equal to N means what is N here? N is 3. Number of unknowns is 3, X, Y, Z. So here you should get a rank must be 3. Here also rank of K must be 3. For that, you have to take lambda not equal to 3. If lambda is not equal to 3, what happens? Then, what happens to rank of A? It is 3. If lambda is not equal to 3, this becomes non-zero. So that you will get a 3 non-zero rows. Rank of A becomes 3. Right? And so, for any value of, or for all values of mu, if lambda is not equal to 3, then rank of K also becomes 3. So this implies R equal to R dash equal to N equal to 3. Here, unique solution. Here in this case, you have a unique solution. Right? System is consistent and unique solution. Next, case 3. What is case 3? Case 3 is infinite solutions. When do you have infinite solutions? R equal to R dash but less than N. Right? So how to get R equal to R dash but less than N? By N is 3 here. N is 3. So R and R dash must be less than 3. For that we take lambda equal to 3. If lambda equal to 3, what happens? This becomes 0 row in A. This becomes 0 row in A. So that rank of A becomes 2, which is less than 3. And also, if mu is also equal to 10, this becomes entire row becomes 0 row in K also. So we take lambda equal to 3 and mu equal to 10. Mu equal to 10. This becomes R equal to rank of A, that becomes 2. And R dash is rank of K, that also becomes 2. Therefore, R equal to R dash, which is 2, which is less than N, where N is 3. Now, R equal to R dash but less than N, in this case we have, or we get infinite solutions. Therefore, infinite solutions in this particular case, lambda equal to 3 and mu equal to 10. So coming to this problem, here show that the equations do not have a solution unless A plus C equal to 2B. So the concept is same. Just like in the previous problem, right? We consider the given system. What is the given system? It is 3, 4, 5. I am writing the coefficient matrix. 4, 5, 6, 5, 6, 7 into X, Y, Z equal to A, B, C. The right hand side constants are A, B, C. Ax equal to B. That kind of a system it is. Now, write the matrix, augmented matrix K. You write the augmented matrix K. What is that augmented matrix? It is 3, 4, 5, 4, 5, 6, 5, 6, 7, A, B, C. Right? Now, you have to convert this into echelon form. Find the echelon form. Reduce this into echelon form. So, how to do it? You have to get zeros in these two places first of all. So, how to get a 0 in this place? Here it is R2 is 3R2 minus 4R1 using R1 only, right? We make these two zeros using R1 only. So, 3 into this minus 4 into this. So, how K is going to transform? No change in the first row. Here it is 0. 3 into B minus 4 into this. 3B minus 4A. Now, how to get 0 here? R3 in this position. You have 3 here. 3R3 minus 5R1. So, it is 0. Right. So, here you get 3C 3 into this minus 5 into this, 3c minus 5a. 3c minus 5a. Okay. Now, our target is to reduce this to echelon form. Next target is to make this entry 0. So, how to do it? R3 minus using R2 only. 2R2 minus 2R2. So, here K will be reduced to no changes in the first row. Right. Second row also no changes. 3b minus 4a. In the third row, this minus 2 into this 0. This minus 2 into this minus 4 plus 4 0. This minus 2 into this. That means 3c minus 5a minus 2 into this. That means 3b minus 4a, which is 3c minus 5a minus 6b plus 8a. This is 3a minus 6b plus 3c. 3a minus 6b plus 3c. Right. So what we have got here is, if you hide this, rank of the matrix A is 2. Right. It is 2. You have only one 0 row. You have two non-zero rows. Therefore, rank of A is 2. But what about rank of K? Rank of K is also 2 if this becomes 0. And you have a possibility of having a solution. So, for existence of a solution, what should happen? We must have 3a minus 6b plus 3c equal to 0 for existence of the solution. This implies a plus c equal to 2b. So, solution exists if a plus c equal to 2b, no solution if a plus c equal to not equal to 2b. This is same as no solution unless a plus c equal to 2b. Both are same. A plus c not equal to 2b unless a plus c equal to 2b are similar statements. Okay. So coming to this problem, this is a homogeneous system. See, you have 0 on the right hand side. So you are asked to find the values of lambda for which these equations are consistent and find the ratios of x is to y is to z for values of lambda, for different values of lambda. So let us write the matrix A. What is the coefficient matrix A here? Lambda minus 1, 3 lambda plus 1, 2 lambda, lambda minus 1, 4 lambda minus 2, lambda plus 3, 2, 3 lambda plus 1, 3 lambda minus 3. Right? So this is the matrix A. You are asked to find the value of lambda for which these equations are consistent. When homogeneous system is always consistent, right? The system is always consistent. But why you are asked to find the value of lambda for consistency means the system is always consistent, but we are always interested in non-trivial solutions. What is the trivial solution? A trivial solution is x equal to 0. That means x equal to y equal to z equal. If you put x equal to y equal to z equal to 0, it always satisfies, right? So that is a trivial solution. You need not solve the system to get the trivial solution. But to find a non-trivial solution, that means infinite solution. By a homogeneous system, you have only two possibilities, either unique solution or infinite solutions. Unique solution is a trivial solution. We are not interested in trivial solutions. So we will find infinite solutions, right? So for infinite solutions, what should happen? For a unique solution, determinant of A must be not equal to 0. For infinite solutions, determinant of A must be equal to 0 for non-trivial solutions. For non-trivial solutions, we must have determinant of A must be equal to 0. This means equal to 0. So directly you can find the determinant of this. You will get a cubic equation in lambda. cubic polynomial equation in lambda, and you factorize it, you will get the values of lambda. Or otherwise, you can simplify this to some extent and continue from there itself to find the polynomial. So I take R2 minus R1 because you have lambda minus 1 and put it in the R2. So what happens? No change in the first row. R2 minus R1 is 0. 4 lambda minus 2 minus 3 lambda plus 1. 4 lambda minus 3 lambda minus 2 minus 1 minus 3. Lambda plus 3 minus 2 lambda minus lambda plus 3. 3 minus lambda. And also I take R3. Here you have 3 lambda plus 1. Here 3 lambda plus 1. So I go for R3 minus R1 and put it in R3. So 2 minus lambda plus 1. So minus lambda plus 3. This minus this 0. 3 lambda minus 3 minus 2 lambda minus lambda plus minus 3. Sorry. Plus lambda minus 3 equal to 0. So here you have some of the entries became 0. So that is the only advantage to find the determinant. So now I find the determinant. It is lambda minus 1 into lambda minus 3 into lambda minus 3 whole square minus 0 into this 0 minus 3 lambda plus 1 into, so leaving this row and column, you will get it 0 minus of 3 minus lambda whole square. Actually it is minus lambda plus 3 is same as 3 lambda minus, sorry, 3 minus lambda whole square. And coming to this, it is plus 2 lambda into 0 minus, this is lambda minus, this is also, this is 3 minus lambda. I take minus common here, you will get 0 plus lambda minus 3 whole square equal to 0. So it is lambda minus 1 into lambda minus 3 whole square minus 3 lambda plus 1 into, here also you can write minus into minus plus you can write, and this also you can write lambda minus 3 whole square. Anyway, you have a square here, you can write lambda minus 3 inside plus 2 lambda into lambda minus 3 whole square. So you can take lambda minus 3 whole square common, lambda minus 1 plus 3 lambda plus 1 plus 2 lambda equal to 0, minus 1 plus 1 gone, lambda minus 3 whole square into 6 lambda equal to 0. So lambda equal to 0 comma 3. 0, 3, 3. 3 is repeated root. You have two values for lambda, different values for lambda. Lambda equal to 0 and lambda equal to 3. Now you are asked to find, for these values the system is consistent and has infinite number of solutions. Right. Now you are asked to find the ratio of x and y, x, y, z for values of lambda. When lambda is equal to 0, what happens? This becomes minus 1 minus x plus y plus 0. From this you get x equal to y. You put lambda equal to 0 in this, you will get minus x minus 2y plus 3z equal to 0. Now put x equal to y in this, what you will get? This becomes minus 3y plus 3z equal to 0. This implies you get y equal to z. So from these two, we have x equal to y equal to z. Therefore, x is to y is to z is 1 is to 1 is to 1. X is to y is to z is 1 is to 1 is to 1 because you are asked to find the ratio. Right. Now, lambda equal to 3. For the value of lambda equal to 3, what happens? If you put lambda equal to 3 here, 2x plus 10y plus 6z equal to 0. You put lambda equal to 3 in this, you will get the same equation. For this also, you will get the same equation. That means you have only one equation. What is that? X plus 5y plus 3z equal to 0. Or x equal to minus 5y minus 3z. Because you have only one equation, but three unknowns x, y, z. Then you have to choose two variables. Choose two values for two variables. I choose y equal to k1, some value k1, some value for z, k2, so that you will obtain the value of k from y and z. It is minus 5k1 minus 3k2. So you have only one dependent variable x, which is depending on y and z. Two independent variables y and z. They are chosen. So therefore, what is x is to y is to z in this case? It is minus 5k1 minus 3k2 is to k1 is to k2. What are k1, k2? k1, k2 are some real numbers. Right. So this is how we can solve these kind of problems. Okay. Thank you. Please like this video, share it with your friends and classmates. Also subscribe to my channel if you have not subscribed yet. Thank you.